Okay, so I'm going to start looking at Boolean algebra. Before I solve this question, I'm just going to explain a few things. So Boolean algebra is basically where we work around with logic and manipulating the and, or, and not operations, right? So there's a lot that you can do with this. For instance, your computer, like the logic gates that run all the operations on your computer, be it addition, subtraction, even you watching this video, most of the logic is built using things called logic gates, which implement this logic, right? So first of all, logic gates, what are they? So first of all, the logic gates that we have the OR gate, which is just this gate over here, right? It's the this is the AND gate. Sorry, this is the AND gate. This is the AND gate, and it will have two inputs and one output. And then for this one, it's only true if both of the inputs are true, or if both of the inputs are 1. So if this is 1 and this is 1, the output is 1. But if it's anything else, then it will be 0. Then you have the OR gate, which is this other guy here, right? The OR gate is a 1 as long as any one of these is 1. You get, right? So if this is a 1 and this is a 0, this will give us 1. If this is a 0 and this is a 1, this will give us 1. But if both are 0, then it gives us a 0. And then you have the NOT gate, which looks something like this. The NOT gate is basically an inverter. So if you have a 1 here, you get a 0. If you have a 0, you get a 1. So that's that. And I'm also going to be playing around with what you can do with this. And then other logic gates are just combinations of these guys, right? And as we encounter questions on them, I'll explain what they do. Okay, then now we have a few Boolean laws that I will share some material that you can read through that we're going to be using, right? That we're going to be working around with as we explain this stuff, right? As we go together. But for now, you can start by solving this question, and from here, I'm going to explain the rule. So we have xy plus xy complement being equal to x. So basically, we want to prove this. I want to prove that okay, xy plus xy complement is equal to x. So how can you do this? Well, there's a simple rule here that we're going to apply, right? The simple rule here called the distributive rule. Basically, if we have a, right? If we have a open brackets b plus c, right? If we have a open brackets b plus c, this we can distribute this a and then have a b plus a c, right? So we can have this if we want, which is basically what we have here. And of course we can factor it. So to prove this one, we're just going to factor out this x. We're going to have x, then y plus y complement, right? Which is equal to, now, before we move on from here, again, another rule to explain is, first of all, what is the complement? Well, the complement, if we have 0 complement, this gives us 1. And if we have 1 complement, this gives us a 0, right? So meaning, basically, if you have 0 complement plus 0, right? This plus operator represents O, right? The plus operator represents the O operation, and then the multiplication represents the AND operation. So now, if you have this one or this one, remember, this one will be a 1, right? So this will be 1 plus 0. And remember, so 1 or 1, this will just give us a 1 there, right? If you have 1 complement plus, that 1 complement plus 1, this will give us a 1 because this will be 0 plus 1, which just gives us a 1 there, right? So we have that there. So yeah, just something I neglected to say. Plus, this indicates the O operation. The dot there or nothing, this represents the AND operation, and then this guy over here represents a complement, an inverse. Then now, it's not always that we'll be dealing with ones and zeros discretely. We're going to be dealing with values like x and y. So one important identity to know is that if you have x complement plus x, this is 1. Right? So imagine if this is a 0 and this is a 1, this will give us a 1. If this is a 1 and this is a 0, this will give us a 1 as well. Right? So no matter what value of x this is, one of them will always be a 1, because in Boolean logic we only have a 0 or 1. And then if you have x complement y, x complement times x, this is a 0, because remember this is an AND operation. So even if this is a 1, the other one will be a 0. If this is a 0, the other one will be a 1. But remember, for the AND operation, we need both of them to be 1s for each to give us a 1. But in this case, both of them can't be 1s because we're getting 1 and the complement of itself, which is 0, or 0 and the complement of itself, which is a 1, which just gives us a 0. Anyway, so now knowing that here we can say, using that identity, we know that if we add if we O an input with its complement, that's always a 1. So it's just x by 1, which just gives us x. So this is how we go about with our first proof, right? This is how we go about with our first proof, because we know that this is always this will always just give us a 1 over there. So next part I'm going to solve this question.